So energy level and electron arrangement is what we're going to look into, and I'll be diving into deeper explanation concerning that. So electrons occupy a particular region of the nucleus and are called energy levels, and they are numbered to 1 to 3, starting with 1 closest to the nucleus. So the first energy level can only accommodate 2 electrons, while the subsequent one can take a maximum of 8 electrons. So as you look at this particular, you push it here, so you realize that the first energy level occupies 2 electrons, then 8, then we have 8. And this is only for the first 20 electrons. Beyond that, it will occupy 18 electrons. So previously I showed you, when we were studying a nuclear, the nucleus, the structure of an atom, is that we have a nucleus in the middle, and we have electron occupies the region we call the energy levels. So one thing you need to note is that the maximum number of electrons that an energy level can hold is given by the expression of 2 and 2, where n is the number of the energy levels. Okay, so the first energy level, that's the number of electrons. What we do is we take 2, then multiply by 1 raised to power 2, because this is the first energy level. Then we get 2 electrons to the second and also to the third. So that's how we determine the energy levels. So beyond the 20 electrons, we'll get that it can occupy even up to 18 electrons. Right, so electron arrangement and electron configuration. So let's dive into that. So this refers to the distribution of electrons in the energy level of an atom. For example, lithium has 3 protons, hence 3 electrons. So the electron arrangement is represented as 2 to 1. Okay. Electron arrangement can also be represented diagrammatically using a dot and crosses, and so that's how it looks like. Okay, so we have inside showing 3 protons and also 4 neutrons, and then outside we draw the dots. In the inner circle or energy level we have 2 electrons, and then in the outer electron we have 1 electron. Sorry, in the outer energy level we have 1 electron. So let's try to draw for magnesium. So for magnesium, because it has 12 protons, 12 neutrons and 12 electrons, it means that it has 12 electrons. Therefore, we are going to fill them into the structure. So the inner one will have 2, then 8, and then 2. So that's how it will look like. So I'll give you an assignment. Try to do electron arrangement for the first 20 electrons. Okay. Element with the same number of occupied energy levels form a period, and a good example is magnesium, which has 282, which indicates that in period 3. Element with the same number of electrons in the outermost energy level form a group. For example, I'll use the same 282. They will be in group 2 because of the last number, right? So characteristics of group is that they have the same number of electrons in the outermost energy level. So all of them will have like 2 in the outermost energy level. Characteristics of a period is they're arranged in order of increasing atomic size. So as you go down, the number will increase, maybe from 1, 2, 3, 4, 5, as you go down. So that will indicate they are the same atomic number. Elements in a particular period are arranged in a row starting with the lowest atomic number. This represents the member of a given period. So those with equal number of electrons in the outermost energy level can also be arranged in a vertical column, and this represents the member of a group. Sorry for that. And there are 8 groups in the periodic table and are numbered in Roman numeral, i.e. group 1 to group 8, where group 8 is also referred to as group 0. Since its members have little tendency to lose electron or either gain electrons during a particular or a chemical reaction. So this is how a periodic table looks like in a sketch, where as we go this direction we are moving in groups, then we are going this way in period, sorry, then when moving downwards we are moving in a group. So all that are here are in a group. As we go this way we are going in periods. So I want to show you a small sketch about a periodic table. So this is group 1, this is group 2, this here are transition metals, this is group 3, 4, 5, 6, 7, 8. So these are the key elements we'll be studying at Form 2 or at high school level. These ones are most key that you need to understand. I'll be able to show you a more complex one, but for now this is what you need to grasp at this particular moment. Okay. So this information can be arranged in a grid to form what is called a periodic table, so where elements are arranged in order of increasing atomic size. So the diagram I've indicated is on this particular page, and you need to know that there are groups of elements between group 2 and group 3 called transition elements, and they are unique characteristics that make them not to be fit in these particular other groups. All right, so thank you so much for listening to me and watching. Let's meet in the next lesson.